Okay. So see, now this lecture is most important. This, I think, third or fourth part of this chapter. Through these different parameters or different curves, at the end we will be able to select the most efficient and suitable pump for our requirement. Okay. So see, uh, as we have discussed that mostly in the designing a pump, again we are dealing with the speed of the impeller, diameter of the impeller, okay, and the head achieved after pumping, and amount of water, and velocities, and the horsepower requirement, that how much power will be required to achieve a specific head. Okay, remember, whenever you are selecting a pump, so actually what we are doing, we are deciding about the horsepower, that how much horsepower motor will be required, yeah, which provides sufficient energy to the pump to achieve the required head. So first you have to calculate your total head. And see, we have discussed that the total head is equal to suction head plus discharge head plus frictional losses. So it is just simple that, for example, here you have the water source, here you have installed the pump, okay, and that is the point where you have required the water. So see, from the center line of the pump to the surface of the water source, that is called what? That is called suction head. Okay, and from the center line of the pump up to the point of discharge, that is called the discharge head. Okay, so you can calculate it in terms of feet of water, in terms of psi, in terms of inches of water. Okay, suction head plus discharge head, and there will be some frictional losses, and we have a general equation, FLV square divided by I think 2G. Okay, so see, suction head plus discharge head plus frictional losses, so you will get what? You will get the total head. Now we have to achieve this much total head, and also how much discharge is required at this point. What will be the rate of flow? Kitna water flow hoga? What will be the rate of flow? And how much head you have to achieve? So per that head and per that discharge, how much horsepower motor will be required? Yeah, how much horsepower pump will be required, which will run at this velocity, which will run at this revolution per minute, which will have this diameter, impeller ka diameter. So these are the parameter to which we are playing. इनके साथ हम play करते हैं, और इसकी base पे we are selecting the best and efficient and economical pump. Now remember, the representation of these parameter, the representation of these parameter graphically, this is called the, these are called the characteristic curves. ठीक है, इन पैरामीटर्स का जो ग्राफिकल रिप्रेजेंटेशन है ना, उनको पंप्स का characteristic curves कहते हैं. And based on these characteristic curve, we are selecting the best efficient and economical pump. So see, the graphical representation of pump performance data, like speed of the impeller, diameter, head, water power. See, one is the power added into the water. That is the water power. Remember. And second one, we have the brake horsepower. That is the shaft power. Okay, the power added into the impeller, mean motor से जो power आ रहा है impeller को, that is the brake horsepower. Okay, or that is equal to omega t. T is the torque, omega is the angular velocity of that shaft. ठीक है, or the power which is added into water is equal to gamma QH divided by omega t. This is also a type of efficiency. that this much power is added into water and this much power is supplied into the impeller. So that is called the efficiency. जी कौन रेस हैंड किसने किया है? जी someone raised hand. कामरान ने भी, आपने किया?
सर शायद गलती से वो
जी जी कामरान,
सर शायद गलती से वो
आवाज नहीं आ रही है आपकी, या मैसेज में लिखे
सर वो कह रहा है कि
अगर कोई
गलती से
क्वेश्चन
हुआ
है
है।
तो। जी
सर कामरान कह रहा है कि शायद गलती से हुआ, तो आप स्टार्ट करें।
अच्छा 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 ठीक है. So see, just we are making the difference between the water power and the brake horsepower. ठीक है, water power is the power added into water, and brake horsepower, that is the shaft power, that is the motor power coming into the impeller. So it will be in term of omega t. ठीक है, omega is the angular velocity and t is the torque. ठीक है, and the output power will be unit weight of fluid discharge which you are pumping and the head which is required. And see, that head is the total head. Okay, that power, and v is the velocity. So the graphical representation of these things is called the characteristic curves. And remember, these will be achieved experimentally. Remember, for each and every pump, first when they are manufacturing a pump, so at that time they are also preparing their characteristic curves. Okay, when you buy a pump from the market, so you will get a type of template, और उस template में ये curves होते हैं. ठीक है, so experimentally they are suppose operating a pump at n speed, having d diameter, so they are varying the discharge, so the head will be variable and they are getting some curves. ठीक है, अगर specific n है ना, suppose n is 1000 revolution per minute, n is 1000 revolution per minute. For example, diameter is 14 inches, and now suppose you are changing the discharge, so obviously the head achieved will be different, the power requirement will be different, the velocity will be different, the water power will be different. Okay, so based on this phenomena, experimentally they are preparing some curves which are called the characteristic curves of that pump. So now we have some standard characteristic curves are available. Now suppose what is your actual requirement? Suppose this much discharge is required at this much head. Okay, so these two are the practical data. ये field data है, ये आपने find करना है, ये आपका requirement है, this is your requirement. Now based on these requirement, from the characteristic curves you will select the required pump. ये designing है इसमें. ठीक है, so first you will understand that the graphical representation of discharge and head at a specific speed and diameter, that is called the characteristic curve, या that is called the performance curve. ठीक है, जी क्लियर हो गया? ये फर्स्ट स्लाइड characteristic curves क्या है?
यस सर।
जी जुल्करनैन जी, आपने हैंड रेज किया हुआ है.
यस सर, एक मोटर है ना सर, उनकी मतलब जो नंबर ऑफ रोटेशन या रिवोल्यूशन है ये एन और बी है, तो सर वेरिएबल नहीं होता ना सर, तो सर वो मोटर फिर कैसे मतलब उनकी जो हेड होती है वो वेरिएबल हो जाती है?
सी, अगर पंप जो है उसको आप इस स्पीड पे ऑपरेट कर रहे हैं, स्पीड कांस्टेंट है, डायमीटर कांस्टेंट है, आप
Yes, sir.
डिस्चार्ज को चेंज कर रहे हैं, डिस्चार्ज को आप इंक्रीज कर रहे हैं, मीन वॉल के जरिए आप डिस्चार्ज इंक्रीज कर रहे हैं पंप का, एन और डी तो कांस्टेंट है। तो सी ये दो जो है, जब पंप ऑपरेट होता है तो क्या होता है, वो हेड को इंक्रीज करता है, मीन वाटर को मूव करता है, वेलोसिटी उसमें ऐड करता है, और दूसरा क्वांटिटी अमाउंट जो है उसको फ्लो करता है ना, दो चीजों के साथ डील करता है पंप, हेड को और क्वांटिटी को। तो अगर ये दो कांस्टेंट हैं और क्वांटिटी आप इंक्रीज कर रहे हैं तो हेड इफेक्ट होगा, बिकॉज अगर वाटर आप इंक्रीज कर रहे हैं ना, तो अगर ज्यादा वाटर आप पुश कर रहे हैं सेम स्पीड पे तो वो ज्यादा दूर तक नहीं जाएगा। फिर अब कॉन्सेप्ट क्लियर हो गया। अगर कम वाटर आप इस स्पीड पे पुश कर रहे हैं तो ज्यादा दूर तक जाएगा, फिर उसका हेड ज्यादा होगा, वो ज्यादा हेड अचीव करेगा।
यस सर,
ठीक
यस सर,
है,
समझ गए। यस सर,
तो
थैंक यू
सी
सर।
if the speed is constant, diameter is constant, you are variating the discharge, so different head will be achieved. Again, different power will be added into water and different horsepower will be required. Okay, now see this graphical representation को देखें, यहाँ पे है, मैं आपको पहले वो दिखाऊं। ये जो है, this is most important. First one, see here we have the pump curve. That is, see, at constant speed and constant diameter. That is the relationship between the head and discharge. इस लाइन को देखें, ये जो लाइन आ रहा है, सपोज आपके पास एक पंप है, if you have a specific pump, so it will have some specific diameter of the impeller, and suppose you are operating it at constant speed, 1,000 revolution per minute. So see, these two parameters are constant. Speed and diameter is constant. Now suppose you are variating the flow. You are variating the flow rate with the help of some wall. So what will happen? The head which will be added into the water, yeah, the total energy which will be added into the water, it will be decreased. And a point will come, suppose अगर आप discharge increase कर रहे हैं, if you are increasing the discharge, so a point will come when the head achievement will be equal to 0 at this speed and this diameter. अगर speed और diameter को आप change नहीं कर रहे हैं, discharge को increase कर रहे हैं, तो एक point इस तरह आ जाएगा कि फिर head क्या होगा, 0 होगा। Okay? Is that clear? This is called the pump curve. When the N and D is constant, then the relationship between flow rate and head, that is called the pump curve. Okay. Now see, we have the brake horsepower curve. It is a type of linear curve, इस तरह increase हो रहे हैं। Brake horsepower means the shaft power, जो पावर जो है, the power which is entering into the impeller of the pump. Now see, again, per constant N and constant diameter, suppose speed and diameter is constant, and you are increasing the flow rate, so more input power will be required. ठीक है, अगर स्पीड और डायमीटर कांस्टेंट हैं और आप डिस्चार्ज इंक्रीज कर रहे हैं, सो मोर इनपुट पावर विल बी रिक्वायर्ड। और अगर आप इनपुट पावर को इंक्रीज नहीं कर रहे हैं तो फिर आपका हेड अचीव नहीं होगा। अगर आपने अपना रिक्वायर्ड हेड अचीव करना है ना, इसी स्पीड पे और इसी डायमीटर पे, और डिस्चार्ज आप इंक्रीज कर रहे हैं, तो आपने इनपुट पावर को इंक्रीज करना होगा। ठीक है, that is called the brake horsepower curve. And one we have the efficiency curve. See, if you are increasing a discharge, if you are increasing the flow rate, the head will be decreased. Remember, और इस पॉइंट को आप देखिए, सी द हेड इज मैक्सिमम बट द डिस्चार्ज इज 0. सपोज रिवर्स आ जाए ना, if the n and d is constant and you are decreasing the flow rate, the head achievement will be increased and a point will occur that there will be no discharge. मीन अक्सर पंप ऑपरेट होता है लेकिन आपको रिक्वायर्ड पॉइंट पे वाटर नहीं मिल रहा. That is called the shut-off head. Now see, if the head is maximum but discharge is 0, what will be the efficiency? Efficiency क्या होगा? जी जी
जीरो होगा सर.
0 होगा. So see here the efficiency is 0. Now at another end, suppose we are increasing the flow rate. So as we have discussed that the head achievement will be decreased and a point will come that you will have the maximum discharge but the head will be 0. So again at that point the efficiency will be 0. So the conclusion is that at 0 discharge, see here we have 0 discharge and here we have maximum discharge. At 0 discharge or at maximum discharge the efficiency is 0. पंप का efficiency क्या होगा? 0 होगा. Now where will be the maximum efficiency? So see, with respect to the increase of the flow rate, the head is decreasing but overall efficiency is increasing up to a certain point. Now beyond this point, if furtherly you are increasing the discharge, the head will be decreased and the overall efficiency will be also decreased. So this point is called the best operating point, या this is called the run out point. ये आपका operating point है because at this speed and this diameter, for this discharge and for this head, the efficiency of the pump will be maximum. So whenever you are selecting, whenever you are designing a pump, so we are looking for this run out point, best operating point. Okay. Now see, in practice, a pump is touched by running it at a constant speed and varying the flow by controlling the valve. Speed is constant and for a single pump, zahiri baat hai, diameter will be constant. So for constant N and constant D, we are varying what? Discharge. Okay. During the test, discharge, pressure, and the brake horsepower will be measured. Suppose you are varying the discharge. So what will be its effect on the head? What will be its effect on the input power? What will be its effect on the pressure? So just note these things. Okay, that at Q1, suppose H1 is this one, brake horsepower is this one. Suppose you have changed the discharge, now the head is H2, the brake horsepower is 2. Okay, now suppose you have changed the discharge to Q3, so head achievement will be H3, brake horsepower will be 3. So you will get different values. Now plot it. So when you plot it, so you will get such type of curve. See, N and D is constant, and for different discharge, you will get the relationship with the head and the brake horsepower. And at the same time, also you can find out the efficiency, because the efficiency is equal to gamma HQ divided by the input horsepower, brake horsepower. Okay, so here you can also get this efficiency, that at this time efficiency will be sigma 1, sigma 2, here is suppose sigma 3. So you can draw the different curves that are called the characteristic curves. Okay, dp is the differential pressure, Murad Ali. Okay, differential pressure, yeah, the change in pressure, yeah, that is the head. Okay, during the test, discharge will be measured, head will be measured, brake horsepower will be measured, and also you can calculate the efficiency. So then you can plot these things, that for different discharge, what is the head, different discharge, what is the brake horsepower, different head, what is the efficiency. Okay, so see, per head and discharge you will get such type of karo, per efficiency you will get such type of karo, and per brake horsepower you will get such type of karo. So these three karo will intersect at a specific point, that is called the best operating point. Okay, that when you operate this pump at the given speed and given diameter, so for this much head and this much discharge, its efficiency will be maximum. Okay, and also these things can be achieved by some specific equation. Sometimes these such type of equations are available on the motor या on the pump को अगर आप देखें ना, तो उसमें अक्सर such type की polynomial equations होते हैं, that for this specific pump, अगर एक specific pump है ना, तो उसका speed और diameter constant होगा. Now suppose you are variating the discharge, so what will be its effect on the head? So the relationship of head and discharge are sometimes represented by this equation, that if n and d is constant, what will be the relationship between discharge and head? Okay, so in this equation, the head will be in feet of water and discharge will be, that is barrel. बैरल सुना है कभी इसको? ऑयल को अक्सर मेजरमेंट के लिए यूज करते हैं ना, कि ऑयल का बैरल इतने पे है, इट इज अ यूनिट ऑफ वॉल्यूम, barrel per day. Okay, barrel per day, and that is equal to 42 gallon per day. गैलन में उसको अगर आप कन्वर्ट कर ले, 42 गैलन होते हैं एक बैरल में, और एक बैरल में जो है 159 लीटर्स होते हैं. 159 लीटर per day. So just for the sake of the unit of this parameter, that in this equation, discharge will be in barrel per day and the head will be in feet. Okay, so from this you can achieve the relationship between head and discharge for a constant speed and constant diameter. Okay, now see, these three curves are explained. One is the pump curve, that is the relationship between head and discharge at a constant speed and diameter. Second one, we have the relationship between the discharge and the brake horsepower at a given speed and diameter. And this one is the efficiency when you are variating the flow rate. Now this one, that is the system curve. See, whenever you install a pump, so then that is called the system, because there will be discharge pipe, there will be suction pipe, there will be some walls, there will be some connections, there will be outlet point, there will be inlet point, so there will be some frictional losses. So when these things are accounted into the pump, then it is called the system. Okay, in overall system में तो फिर जो relationship है, that is this one, ये करो है फिर उसका. ठीक है, तो ये चारों करो जो एक पॉइंट पे मीट होते हैं, that is called the best operating point. Okay, and whenever you operate the given pump for this discharge and this head, it will give you maximum efficiency. Now see from that characteristic curves, H is almost constant at low flow rate. See, at up to here, there is, let me clear this thing. See, at low flow rates, there is not too much variation in the head. अगर करो को आप देखिए ना तो ये a little bit straight आ रहा है. अब ये illustration है, ये explanation है इन curves का, that at low flow rate there is not too much variation in the head. ठीक है, और इस पॉइंट के बाद अगर आप देखें ना ये कर्व स्टीप हो रहा है, the curve is becoming steep. So at higher flow rates there will be steep variation in the total head. Second point क्या है? Maximum head will be is at zero flow rate. Mean when the flow rate is zero, the head will be maximum, and that is called the shut-off head. Okay. Now head drops to zero at discharge is maximum. See, when you are increasing the discharge, so the head achievement is, when the head is increasing, when the discharge is increasing, the head is decreasing. So at maximum discharge, the head will be zero. And at zero discharge, the head will be maximum. So these are the 2 points at which the efficiency is zero. See, efficiency is always zero at Q is equal to 0 and Q is equal to maximum. If the discharge is maximum, then the head will be 0. And if the head is maximum, if the head is shut-off head, then the discharge will be 0. So at both cases, the efficiency will be 0. Okay? And see, the discharge will be not greater than the maximum discharge. See, at maximum discharge, the head is 0. So that इससे आप आगे नहीं जा सकते फिर, because negative head तो हो ही नहीं सकता. ठीक है, तब तक जब तक आपने n और d change नहीं किया हो. Mean if n and d is constant, then the discharge will be not greater than the maximum discharge. And maximum discharge is that one at which the head is 0. Okay, so efficiency is not an independent parameter. See, efficiency is depend on what? Head and discharge. And if any one of these two is 0, then the efficiency will be 0. Okay, so see, head is maximum, but the discharge is 0, so the efficiency will be 0. Now, if the discharge is maximum, then the head will be 0. So again, the efficiency will be 0. And see, 60% of the maximum to 93% of the maximum discharge. At that portion, the efficiency is maximum. See, in here the discharge is 0 at this point. And see, here the discharge is maximum. So from this point up to this point, if you look, the efficiency is maximum. So from 0.6, अगर आपके पास जो discharge है, if it is 0.6 time of the maximum discharge to 0.93 time of the maximum discharge, अगर डिस्चार्ज इस रेंज में है तो इफिशियंसी जो है वो मैक्सिमम होगा. ठीक है, इफिशियंसी विल बी मैक्सिमम एट रफली 0.6 टाइम ऑफ द मैक्सिमम डिस्चार्ज टू 0.93 टाइम ऑफ द मैक्सिमम डिस्चार्ज. ठीक है, और जहां पे इफिशियंसी मैक्सिमम हो, दैट इज कॉल्ड द बेस्ट एफिशिएंसी पॉइंट. ठीक है, और इसी टाइम पे जो मीन जिस पॉइंट पे इफिशिएंसी मैक्सिमम हो ना, तो उस टाइम पे जो डिस्चार्ज है एंड एट दैट टाइम हेड एंड पावर, दीज आर कॉल्ड द डिजाइनिंग पैरामीटर. मीन डिस्चार्ज, head and power at which the efficiency is maximum, that is called the best efficiency point. ठीक है? So these are the characteristic curves of the commercial centrifugal pumps which are locally available in the market. Okay, so these curves are available in the template along with the pump. So from that you can select कि इस pump को हम कितने head और कितने discharge के लिए use कर लें. Okay. Suppose if you directly buy a pump from the market, so you can decide from its characteristic curve that for how much discharge and how much head, the efficiency of this pump will be maximum. Okay. So see, sometimes these standard curves are available. One is called the performance curve. ये जो gray color के lines है, these are called the power curve. Now suppose these are the standard curves. अगर आपके पास ये curve है ना, ये कागज पे print कर लें, इस एक शीट से भी आप जो है पूरा डिजाइन कर सकते हैं. ठीक है? So see, for example, if your total head requirement is this one, and this is your discharge requirement. Okay, your head requirement and discharge requirement is this one. Suppose that is the point. Mean this much head is required. For example, 19 feet. And suppose this much discharge is required. 600 gallon per minute. ये जो red point है ना, suppose this is your requirement. And see, this will be calculated practically that how much is your suction head, how much is your discharge head, how much is the frictional losses. So sum of these three will be the total head requirement. And also how much discharge is required for your processing operation. So see, for example, this much discharge is required and this much head is required. Now suppose if you change the Q1, if you have required this much discharge, so how much head will be then required? If you change the discharge to Q2, then how much head will be required? And see here the frictional losses will be also included because that is your actual system curve. So you practically prepare the system curve according to your requirement. Okay, mean that is the practical curve, that is your required curve, that is your system curve. Now superimpose this curve. Mean ये एक प्लास्टिक पे इसको ड्रा कर लेना, ट्रांसपेरेंट प्लास्टिक पे, और उस प्लास्टिक को इन कर्व्स की ऊपर रखें. Just place the transparent system curve on these curves. Suppose ये point यहाँ पे आ रहा है, which is your requirement. So see now how much horsepower pump is required. See ये जो gray line इसके साथ intersect हो रहे हैं, 7.5 horsepower. इतना pump आपको required होगा at this much speed, which will revolve at 540 revolution per minute. So if you select a pump of 7.5 horsepower and suppose you operate it at 540 revolution per minute and having the diameter of 16 inches, mean ये curves जो हैं, so it will give you this much head and this much discharge. ठीक है, तो इन कर्व से भी आप डिजाइन कर सकते हैं. That first you prepare the system curve for your required position, for your requirement. First you prefer the system curve on a transparent sheet. एक plastic sheet पे इसको draw कर लें. Then superimpose this curve on these standard curves, and the point which is your required point that this much head is required and this much discharge is required. So वो point कहाँ पे आ रहा है, where it lie? So see, the point is coming here, which is intersecting this gray line. So this much horsepower pump is required, and see, it is intersecting this blue color line. So you have required this much horsepower pump, which will need to be operated at 540 revolution per minute. So it will give you 600 gallon per minute discharge and 19 feet head. ठीक है? So these are the characteristic curves through which you can design, through which you can select the best efficient pump. So अगर आप इस तरह पंप सेलेक्ट कर लेना 7.5 हॉर्स पावर का और इस स्पीड पे उसको आप ऑपरेट कर लें तो वो आपको 19 फीट हेड देगा, 600 गैलन पर मिनट डिस्चार्ज देगा, एंड दैट विल बी द बेस्ट एफिशिएंट पॉइंट. मीन इस टाइम पे उसकी जो एफिशिएंसी होगी वो मैक्सिमम होगी. ठीक है
सर
जी.
सर ये जरूरी तो नहीं है ना कि वो ग्राफ इसी ग्राफ को मतलब टच करे, इन बिटवीन भी आ सकता है इन लाइंस के दरमियान.
एग्जैक्टली. सी सपोज अगर पॉइंट जो है यहां पे आ जाए, if the point come at the middle, जो आपका required point है कि this much is your required discharge and this much is your required head. Now how much horsepower a pump will be required and at how much speed you will have to operate, so then you will have to interpolate. Interpolation कर सकते हैं फिर.
यस सर इस डेटा से सर कर सकते हैं क्योंकि नीचे डिस्चार्ज गिवन है और लेफ्ट साइड ऊपर वर्टिकल पर टोटल हेड मौजूद है.
जी दोबारा बताएं, मैं आपके पास ही नहीं आ रहा.
सर ये नीचे जो लाइन है ना सर, टोटल हेड और क्या होता है डिस्चार्ज के थ्रू से सर हम इंटरपोलेट कर सकते हैं ना.
सी सपोज अगर आपका पॉइंट जो है बीच में आ रहा है, now suppose that is your discharge and that is your required head, you can see that at this point, see horsepower is 15 horsepower, suppose that is HP1 and the speed is 700 revolution per minute. See ये जो green करो है, ठीक है, that is N1. एंड एट दिस टाइम इस पॉइंट पे देखे ना, इस पॉइंट पे जो डिस्चार्ज है सपोज दैट इज Q1 एंड एट दिस पॉइंट जितना हेड है सपोज दैट इज H1. सिमिलरली एक करो यहां से ले ले, सपोज दिस इज द पॉइंट. सो इस पॉइंट पे जो हॉर्स पावर है फॉर एग्जांपल दैट इज HP1 एंड दिस करो इसका जो स्पीड है सपोज HP2 सॉरी that is N2 and the discharge at this point is Q2 and the head at this point is H2. Okay, now our discharge is Q, तो कितना हॉर्स पावर इसके लिए रिक्वायर्ड होगा. Okay, discharge is or given और अपने लेना है. So then you will have to do the interpolation. Q minus Q1 divided by Q2 minus Q1 is equal to horsepower minus horsepower 1 divided by horsepower 2 minus horsepower 1. तो ये interpolation है. Q आपके पास given है, you will get the horsepower that for this discharge how much horsepower is required, and also you can calculate the speed कि उस हॉर्स पावर मोटर को या पंप को आप कितनी स्पीड पे ऑपरेट कर लें तो आपको इतना डिस्चार्ज और इतना हेड अचीव होगा एट अ बेस्ट एफिशिएंसी पॉइंट.